Hello and welcome to another episode. Today's topic is auto scaling. Auto scaling. Thank you so much for your love and support. Auto scaling. There are three types of auto scaling. First is HPA, VPA, and CA. It is called as horizontal auto scaling, horizontal pod auto scaling, vertical pod auto scaling, and here is cluster auto scale. What is horizontal pod auto scale? Just giving you an example. When too many guests arrive at home, Mama says, "Oh God, I wish I had more hands." In Hindi, you can say, "Bhagwan, mujhe do haath aur de do." This is like a vertical auto scaling in Kubernetes. You are adding resources in existing pod, so it can handle task efficiently, just like Mama wants hands to manage the chaos. And it is known as vertical auto scale. Mama don't say, "I wish there other Mama." That is the horizontal pod auto scaling. Means we can create pod. Means this pod we can create instance, or instance can be created to handle the load. Mama don't want another Mama to share the load, but technically this is more useful. It is rarely used, or because here it require pod to restart. And in cluster auto scale, it is handled by cloud addition or removal of node. Means scale in and out of node. It's a auto scaling, cluster auto scale. So HPA scales number of pods. Pod 1, pod 2, pod 3. VPA adjusts resource request, increase or decrease. Hence CA scales nodes, scale in, scale out, to ensure there is enough capacity for the workloads. If the nodes are in pending state and CA is configured, so this comes into the picture. So let's have a comparison. Features: horizontal pod auto scale feature, horizontal pod auto scale, VPA and CA. What it is scale? Number of pods, CPU memory of pods, and here number of nodes. Scale directions means count of horizontal means pods, pod size, and it's a node count. Matrix dependency, yes, there is resource uses and scheduling constant like pending nodes. Restart, pod restart, no, yes, required, here no, because schedule in another nodes. Metric server, yes, required for all. There are many things. Here one more thing, key parameter. It's a min replica, max replicas, and metrics. Example, you can CPU utilization or custom metrics. Here update policy, target reference, CPU memory resource request based on pod scheduling. Great. So just in brief, HPA automatically adjusts the number of pod in a deployment or replica set based on observed metrics like CPU, memory, or custom metrics like HTTPS request and something. How it works, it continuously monitors the specified metrics and compares it against the predefined threshold. If metrics exceed or falls below the threshold, HPA scales the number of pod up and down. And there are behaviors also, so that after that matrix regulates or below the threshold, it will scale down. Vertical pod auto scaler. VPA automatically adjusts the resource request, CPU and memory for individual pod to optimize uses. It works by analyzing the actual memory or CPU for the pod. It continuously monitors the pod uses and adjusts the resource request, not the replicas, to ensure efficient resource allocation. VPA works with the workload where you want to scale resources rather than number of pod. If suppose pod is underutilized, so it will reduce the resource request for better resource utilization. And for CA automatically adjusts the number of pod in Kubernetes cluster based on the resource requirement. It helps to ensure that there are enough nodes to support workload but also prevent over provisioning. It monitor cluster, worker node 2. It monitor cluster and checks any pods are unscheduled due to the lack of resources. Means if pods in a pending states, if many pods in a pending state, then If there are unschedulable pod, CA adjusts new pod to new nodes to the cluster. If nodes are underutilized, CA can scale down the number of nodes. CA work on the cluster level and automatically scale up and down the number of nodes. It primarily concerned with the node level. In cloud environments like AWS, GCP, CA works via cloud provisioning. To understand the autoscaling or horizontal pod autoscaler and vertical pod autoscaler, we'll have scenarios. So we'll look case 1 where deployment has 1 replicas. An HPA created with minimum replicas 2 and maximum replicas 4. And scale down stabilization window second, I can say it's a 30. Case 2 deployment replicas 2. HP created with minimum replicas 1, max replicas 4 and scale down window second is 30. And it is created, and after the creation, if the utilization decreases below threshold, then how HPA behaves. Okay, I will write auto scale YAML file. You can search HPA in kubernetes.io, and so you can find it that php-apache.yaml file. It's a API version. I'm writing it here so that you can have little focus on YAML file. Auto scaling /v2 kind. Kind is horizontal pod auto scaler. Here H is capital, P is capital, and A is capital. Metadata. Name is very important. php-apache. I'm not changing any name. You can find this YAML file. The spec. This is very important. Scale target reference. API version. Here you should mention the API version of targeted ones, which is most of the time deployment or stateful sets. Rarely is replica set. Nowadays only few using replica set. Kind is deployment. And name is Apache. This name is correspond to the deployment. Now the minimum replicas and maximum replicas field. It's a plural. It's a 1. Max replicas. I can say it's a 3. I put 3 here. Matrix. This is important because these two work. Matrix server it has to be installed. And we'll install matrix server, no issues. I already uploaded the documentation for the installation of matrix server. Here is the type. Here is the resource and resource. You can mention one resource or means you can do one resource or many resources like CPU memory. Here I am mentioning CPU and target type utilization and average utilization. This is the threshold. Average utilization equal to, it's up in percentage. Most of the time it is set to 50. Now behavior. Spelling is a little different. BEHAVIOR. Scale down. Stabilization window seconds. To consume less time, I will set it to 30. Okay. This reference to the deployment. Okay. Now come to the killer CUDA and we'll have deployments and rest of the things. Now it's a demo time. I'll refresh playground. Most of the thing I will copy paste, but you try to write it down because it helps to practice. Don't maximize your window because you don't have any liberty to work in maximize window in CKA exam or any of Kubernetes exam. I'll make this a little small. Now first thing, matrix servers to be installed. So I will first check matrix server is present or not. Error from the server means it is not installed. Now we have to install it. Just you have to copy paste. I will post once again, or I will share the link in comment. Killer CUDA often use self-signed certificate, kubelet certificate, so need to kubelet insecure TLS. So we are patching. Wait for matrix server to roll out. Deployment matrix server successfully rolled out message will be there. Yes, matrix server successfully rolled out. Now we'll check it's working or not. Sorry, it was copied. This will be in true. Just check matrix server. Kget k top nodes, k top pods -a. I'll make it little so that I'm extending it so that you can see full window. Here you will see CPU and memory utilization. Here 58% and control plane. It's a node is 49%. 48. CPU is 2%, 13%. Great. Now first I'll search HPA, horizontal pod autoscaler walkthrough Kubernetes. Here you will find application Apache YAML. Copy this, make demo autoscale.yaml. Paste. This is not required. Oh shit. I'll paste again. This is the deployment, and now autoscale HPA. Now I will copy this YAML file, paste it here. I will not change anything because here you will find scale target reference. This I will show you. You will see PHP name deployment and this one. So I'm referencing it here in scale target reference. Same thing, don't typo here. Okay, I'm here in Killer Coda. There is not much resources available, so I will make it 3. Okay, average utilization, I am not changing anything. Now adding one more behavior, scale down stabilization window second. I will copy it here. After copying, you will always find this shifted to left, properly indented. Now WQ. Okay, now I will apply deployment. Here container creating is now running. Okay, means our deployment is running with the 1. Here deployment details and here the pod details. Okay, now here is minimum replicas is 1, maximum replicas is 10. Matrix server is already installed. Now I will apply HPA YAML file. Now you'll see here unknown. It will take a little time to update because matrix server is already installed. Now it is showing. Here you will find that reference is deployment PHP Apache. This is the auto is name of our auto. This is the deployment. This is the target. Here you will see minimum pod, maximum pod, replicas and age. Okay, great. Now I will just make it watch. Okay, and I will increase the load. Already given that how to increase the load. I'll just copy this increase the load. I will paste in another terminal. Paste. Here you will find replicas will increase. Actually it's a 15 second cycle because controller takes a 15 second approximately to fetch the metric server. So you will find this minimum pod replicas here will update. I think it's what I had done. I had copied full command or what, because it should run okay paste. Oh sorry, delay for generator. Now I will run this command. Why this is sorry, need services also need to create. Just I will create this service. Now I will paste this now I'll paste that command, this done command, paste. Okay, now you will see the load will increase. Here load is 79. It is more than that 50%. So you will find replicas to 3, replicas is to 2, replicas to 3. Now I will shut off this load. Let's watch again. Here the CPU load is decreases. It is actually controller fetch in 15 seconds. So this action you will see in 15 seconds. You will see it's here 3, load is 16%. Now it will take 30 seconds for the stabilization. This property behavior scale down stabilization window seconds. So it will reduce the replicas to 1. Look here, replicas to 1. Okay, means we understand how the HPA works. Now we'll have 2 scenarios where deployment having replicas 1 but HPA created with the replicas 2 and 4. So it will not wait, it will directly update with the minimum replicas to 2. Close this. That autoscaler is deleted. Demo autoscale an HPA. I will make changes to here 2 and here max replicas to 4. Okay, get pod -o, sorry, -w. You'll see 1 pod is running. Now I will apply dem HPA and see here. That is not showing. You'll see this pods are running, 2 pods are running, 2 pods are running. It immediately increases minimum replicas because when you target, when you reference any deployment, then that HPA property will work. Now the second case, deployment has replicas 2 and minimum replicas to 1 here. So I will edit deployment. Already is showing 2. I'll delete. There's a deployment is of replicas is of 2. Now I will minimum replicas 1 and maximum is 4. Demo to scale -HPA. Now I will make it 1. It will immediately it will not wait for that scale down period. It will immediately scale down to 1. Now it's a 1 pod, and it will check the replica set to 1. So thank you so much for your love and support. Stay tuned, we'll have a lot of content. Thank you so much.